Okay, here are the notes. Take these down, write them down, don't just watch the video. All right, this is notes, and it ties into logarithms, so we really got to know this well. Solving equations. Solving equations with rational exponents. Okay, let's see if I can focus this a little better. Oh, I think that's the best it's going to get. Solving equations with rational exponents. Okay, so pretty much we're just going to be working with bases and exponents. And the key thing here, is to make sure you get the same base. You have to have the same base. Get or have the same base. That's going to be the main priority first. Once you get this, the rest is going to be easy. Okay, here it is, solve. So let's just jump into these. So this is what I mean by getting the same base. So let's say, for example, for number 1, we'll have 3 to the power of 2x plus 3 is equal to 3 to the power of 5. Okay, so obviously number 1 is easy. It's the first one. Why is this the easy one? Well, because here you can see that they already have the same base. The 3 is the base. See, this is the base. We got to get the same base on both sides of the equation. Okay, and that's already true here. See, later you're going to see problems that don't have the same base. But for right now, for these first easy ones, when they have the same base, and let me just copy this again. Over here, 3 to the power of 2x plus 3 is equal to 3 to the power of 5. See, once the bases are set equal, right? Once the 3 is equal to the 3 here, then you can look up here to the exponents, right? These up here are the exponents. And now, it doesn't matter what this base is, but once they're equal and once you make these to match, then if 3 is equal to 3, now the exponents can be set equal to themselves. Exponents. So again, once this base is the same, I don't care if it's an 8 and an 8 or a 4 and a 4, but once you get these to match, then here's where you're going to solve for the exponents. And this is where you'll put the exponents equal to each other. So this will be what? Well, you'll see here, this is a 2x plus 3 equal to, and then whatever's over here, 5. And then this is where you're going to solve. So then you're going to solve exponents. You solve for the exponents. But you got to make sure the bases are the same. So once you have that, and then this part on top should be pretty easy to solve, right? How do you solve this? Well, 2x plus 3 equals 5. Move that positive 3 to that side. That's going to be 2x is equal to 5. Not positive 3. When you move it to that side, it'll be negative 3. That'll be 2x is equal to 5. Take away 3 is 2. 2 times what is equal to 2? Well, x is equal to 1. Okay, let's see one more where the bases are equal to each other. Okay, well, number 2. What if you have something like 4 to the power of negative 3x minus 3 is equal to 4 to the power of 3x plus 1. So again, we're just working with bases and exponents, but right now your first worry, your first concern is to make sure that these are the same. If these are the same, then we're ready to just work with the exponents. But these have to be the same. Well, they are. They are the same. Same base. Good. That's what we want. We want the same base. And if that's true and the bases are the same, then you just have to, if 4 is equal to 4, then we put the expressions for the exponents equal to each other. Whatever expression is here, whatever expression is here, number or expression, once the bases are the same, we put those equal to each other. And that's where you solve, right here. So I don't need to worry about the 4 equal to the 4. I just set the negative 3x minus 3 on this side equal to 3x plus 1. And that's just an algebra one step, two step, or multi-step problem to solve. And that will be this negative 3x comes to this side. So that'll be negative 3 is equal to 3x, which is here, plus this other 3x. This is coming over, plus 1. That'll be negative 3 is equal to 6x plus 1. Now you move this positive 1 to that side, so that would be negative 1 minus 3 is equal to 6x. Right, this positive 1, I moved it to this side, so it became negative 1. Negative 4 is equal to 6x. Okay, here we're going to get a fraction. Divide by what? Well, I want to get the x alone. Isolate the x. Divide by 6. Divide by 6. You're going to get x is equal to negative 4 over 6. So final answer for that one. X is equal to, when you reduce x is equal to negative 4 over 6, you get negative 2 over 3. Okay, let's look at the ones that do not have the same base. What's going to happen there? Okay, number 3. That'll be something like this. What if you have something like 4 to the power of negative 2n is equal to 16. 4 to the power of negative 2n. See, here they do not have the same base. Bases must be the same. The bases must be the same, and they're not. See, I can't do this problem right now. The bases have to be the same. This is a 4, this is a 16. So, well, if I have 4 to the power of negative 2n is equal to 16, I'm just going to copy it over again. Can we get, let's look at this smaller number, which is a 4. Can I write 16 with a base of 4? Can I do that? Yes. You can write 16 with a base of 4. 16 is the same as what? 4 what? 4 squared. See? I want it to match this one. So I write 16 as 4 squared, and this one I just keep the same. This one I kept the same. And this one I rewrote it so that they have the same base. Right, see, now they have the same base. Now I can solve this, right? Once the bases are the same, then you just, once this 4 is equal to this, then you set this and you solve it over here and you put those, whatever the expressions are, the exponents, you put them equal to each other. So that's going to be negative 2n is equal to 2. Well, that's going to be the easy part, right? N is equal to negative 1. All right, let's pick it up a little bit more complicated. Okay, how about number 4 here? How about 2 to the power of 3n minus 3 is equal to 64? Okay, so I got this 2. Can I write a 64 with a base of 2, right? They don't have the same base. The answer is yes. How do I write 64 with a base of 2? What goes there? That's a question mark. Well, it's going to be 2 to the power of 3n minus 3 is equal to 2 to the power of, well, let's see, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, so guess what it is? 2 to the power of 6 is 64. That's the one. See, you can rewrite this as 2 to the power of 6. 64 is 2 to the power of 6. And now that I have the bases to match, now we just solve here. Once these match, you just solve up here. You just look at the expressions and the exponents and you just worry about that. You put this equal to this one and then you solve it. That'll be 3n equals 9. That'll be n is equal to 3. Okay, now the challenging ones. Okay, what number are we on? 5? Okay, what if you have something like, well, 5 to the power of 2x plus 3 equals 1 over 25. Oh, now we got something like a fraction or whatever. You'll most likely see it for this worksheet just with the 1. We're not going to worry about this one. You just worry about this base here and this number here and try to get the same base. The denominator here, try to get this and this to have the same base. Won't worry about that one. We'll fix that right now. So that's going to be 5 to the power of 2x plus 3 equals 1 over, can you write 25 with a base of 5? Well, of course. 25 is what? 5 squared, isn't it? So you want these bases to match. We don't want this fraction right now. We're going to fix it. Okay, so once you got that to match, now when you have this fraction with a 1 over something like that, again, we don't want this fraction, so we can take this and move it up. Remember what happens with exponents when you move them up or move them down? If it's positive here and you move it up, it turns negative. Or if it's negative here and you move it up, it turns positive. So now your expression or your equation here is 5 to the power of 2x plus 3 equals 5 to the power of, well, this is positive 2, but when you move it up, it'll be to the negative 2, like that. Okay, so now we have the same base. We don't have any fractions. Now we do now that they're the same base, we solve here. We put whatever expression is here in the exponents, we put them equal to each other to solve. We don't have to worry about the 5s anymore. You just worry about this over here. We solve this. Okay, last one like this. Excuse me. Okay, so that's how you deal with the ones that have like a fraction, like a number like this. Last one, number 6, one like this again. 4 to the power of negative k minus 2 is equal to 1 over 64. Well, that 4 is okay. Can I write 64 with a base of 4? Yes, you're going to rewrite this. Rewrite with base of what? Well, look at the one that's here. With base what? 4. So that would be 4 to the power of negative k minus 2 is equal to 1 over what? What is 64? 4 cubed. 1 over 64 is the same as 1 over 4 cubed. 4 cubed is 64, right? Okay. And then again, when you have this situation here with this fraction, and the base is down here, whatever it is, we're going to move it up. And you won't have the fraction anymore. So it'll be 4 to the power of negative k minus 2 is equal to, and when that moves up, that's going to be 4 to the power of what? This is positive 3 when you move it up, negative 3. Don't forget to change the sign. And now we have the same base. And then now you just worry about the exponents and solve here. Set those equal to each other, whatever that expression is, solve it. Negative k minus 2 is equal to negative 3. I'm going to move my k over there to make it positive, and I'm going to move this over here. So that'll be positive 3 take away 2 is equal to k. All right, there it is. Not too bad. Good luck.